Thing I'm going to ask you to do is to take out your graphing calculator and copy this table. Actually, you don't have to copy it if you're using the note sheet that's provided in Schoology. And what I'd like you to do is to calculate, first make sure that you set the mode to degrees on your calculator. Remember, press the mode key, select degrees. Then I want you to find the tangent of all these angles for 0, 10, 20, 30, and so etc., going across the top all the way to 90 degrees. And fill it in where it says tangent of theta. So if you take a few minutes to do that, pause the video and fill in that table. All right, so I'm back and I filled in my table, so you can check your values just to see if there's you got the same things I did. Your rounding should have been the same, so you can see that my numbers were at the tangent of 0 was 0, the tangent of 10 degrees was 0.1763, the tangent of 20 degrees was 0.3640, the tangent of 30, 0.5774, tangent of 40, 0.8391, the tangent of 50 is now bigger than 1. It's 1.1918, and then 1.7321 for tangent of 60. Tangent of 70 is 2.7475. Tangent of 80 is 5.6713. And the tangent of 90, you should have found that you got an error. And we'll talk about why that happens shortly. The next thing I'd like you to do is take, and in this table of sines and cosines, you can see the sine is already calculated for you across the table. So is the cosine. Notice we have the pattern of complementary angles, 0, 0, 1, 1, 0.1736 for 10 degrees is the sine, but that's the same as the cosine of 80 degrees. So we have our pattern that we're familiar with, and we filled in the tangent down below. The next thing I'd like you to do is take the sine and divide it by the cosine. So do 0 divided by 1, and we can start you out with the first one, right? So 0 divided by 1 is going to be 0 divided by 1 is going to give us 0. And then I want you to take 0.1736 and divide it by 0.9848. Complete that as you go across the table. And I'll pause the video while you do that. So you should pause the video. I'm gonna write pause on here. All right, so we're back, and what you should have noticed is that the sine divided by the cosine is exactly the same answer as the tangent. And why do we get an error when we try and take the tangent of 90 degrees is because our denominator, we're dividing by 0, because your calculator is doing the same thing you are. They're dividing sine and cosine. And you can see just by the pattern of sine and cosine that as we get closer to 90 degrees, the sine is becoming closer to 1. So when it's very close to 90 degrees, the sine is a little bit less than 1. But the cosine, as we move closer to 90 degrees, is getting very, very tiny. And so if I have a number that is almost 1 and I divide it by a number that's very, very tiny, very close to 0, but just a little bit bigger, I'm going to get a very large number. And you can see that at the point where we get to 90 degrees, then I'm trying to divide by 0, which we know is not defined in mathematics. All right, the next big idea we're going to talk about is the angle of elevation and the angle of depression. Now, these are both words that are used in normal language, and we're going to talk about what how their meaning is the same or different. So elevation, we might hear that when we talk about elevators going up, right? Also, I mean, and that's really what it means in everyday language, is to elevate something is to lift it up. And in our context, we're going to be talking about lifting up our gaze, an angle of elevation. So when you're looking straight ahead and then you look up, That is what I want you to think of as an angle of elevation, and because that's what the context that it came from. Depression, okay? So a lot of us are maybe not feeling so hot because we're stuck inside with this COVID and different things. So depression is in everyday life, means that you're not feeling so great, right? Or you're feeling down, right? But in our context for math, we're talking about an angle of depression, and this would be where you would look down. So if I'm looking straight ahead, and I need to look down, at maybe I'm looking down into a valley or down into a hole. That's going to be the angle of depression. Or I might be up in an airplane or something, and then I look down, and I would measure that angle as the angle from looking straight ahead to looking down at the object I'm looking at. So an angle of elevation might look like this. So I'm looking straight ahead. So here's me. That's my eyes, and I'm looking straight ahead. And then I look up and I see an airplane up here. So here's or a bird or something. And so this would be my angle of elevation. Similarly, if I was talking about an angle of depression, so I'd be looking straight ahead, and then maybe I look down and I see down here that there's, maybe there's something on the ground. Okay? So this would be my angle of depression. So it's always from the horizontal, from looking straight ahead. So the first problem we're going to look at is an angle of elevation problem. So here we have a young man named Scott, and he's walking along the ground, and we can see that there's a tree above, or a tree in front of him, and then up at the top of the tree there's a cute little bird. So remember, this is a picture, but in math we prefer diagrams, so I'm going to re-diagram this picture, and the picture is going to look like this. So here's Scott's eyes, and when he looks straight ahead, then he hits the tree, and up in the top of the tree is the bird. So I'm going to call the bird B. This is Scott's eyes. And so you can see that he's looking up from the horizontal. The tree, the problem says, is 30 meters away. So this is 30 meters away. You can see we get a right triangle there. It also says that Scott is 1.5 meters tall. So remember, when he's looking up, he's actually got some height. His head is not on the ground, right? He's got some height of 1.5. So that'll be important as we answer the question. So he's 1.5 up from the ground. And the question is, how high is the bird in the tree? And so we're going to use the angle of elevation. They tell us that this angle, the angle of elevation, is 36 degrees. So you can see we have enough information that I should be able to find this vertical distance above Scott's eyes, for how high the bird is above his eyes in the tree, based on this angle of elevation and this distance he is from the tree. Now, when the actual question, though, is how high the bird is off the ground. And so once I find this height, I have to remember that Scott's eyes are 1.5 meters off the ground, so I'm going to have to add in that extra height down below here, because he's not, his head is, like I said, his head is not on the ground. He's got a certain amount of height off the ground here that we have to add in, and that's that 1.5 meters. So we can use trigonometry to do this. We're going to use the tangent to do these problems, because tangent is very useful because we don't need the hypotenuse. And so in this case, we don't have the hypotenuse, and we don't need it because we're going to use the tangent. So remember, tangent is defined as the ratio either sine divided by cosine, but we don't, remember, both sine and cosine use hypotenuse. We don't want that, but we saw that we could get tangent by doing the opposite over the adjacent. I should, just as an aside, point out that if tangent is sine divided by cosine, and the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse. When we divide fractions, we invert, so I have opposite over hypotenuse times hypotenuse over the adjacent. And you can see the hypotenuses are going to go away, and we're just left with opposite over adjacent. So mathematically it works out. So back to this problem. So we have our tangent is opposite over adjacent. So the opposite side I don't know. I'm going to just give this an x. And so the opposite over adjacent is going to be the tangent of 36 degrees equals x over 30. So x is going to be equal to 30 times the tangent of 36 degrees. And using the tangent key on your calculator, remember you set your mode to degrees, 30 times the tangent of 36 is equal to 21.79. So we're going to go to the nearest tenth. So I'm going to say that's 21.8 meters. That's this distance right here. That's how far the bird is up the tree. And then we have to add in the 1.5 meters from the ground. So when I add those two, I'm going to have 21.8 plus 1.5. And that gives us 23.3. So the answer is this bird is 23.3 meters above the ground. All right, this next example is an angle of depression. So here we have John, and John is way up on this building. Okay, so he's standing on the roof. And down below, so the building, we were just seeing the roof, and then this is the side of the building. And then down below here on the ground is John's friend, little tiny person. And what's happening is the rooftop is 16 meters from the ground. So this is more like a diagram than a picture, right? So although we made little people up here, for John and his friend, we might want to make it more like a math diagram. We might want to put J for John and F for friend, right? And so here's our building, and it says he's standing on the rooftop. The building is 16 meters from the ground, the roof, and so this is the distance is 16 meters. John's eye level is about 1.8 meters from the rooftop. So if you look at John's eyes, he's actually a little bit higher than the roof. He's got a height here of 1.8 meters. Actually, I don't like the way this looked here. So 1.8 meters. So here's his eyes. This distance right here is 1.8 meters additional height to the roof. So when we're calculating this, we're not going to use 16 meters, because when he's actually looking, he's actually going to be looking from 17.8 meters high. So it might be better if we just draw another triangle when we do that. And we want to know how far is John's friend from the building. So when John looks down at his friend here, you can see we get a right triangle. But this right triangle, I'm gonna redraw it here, has a height that is not 16. This height is 17.8. Oops. So this is 17.8. And the friend, we don't know how far he is from the building. That's what we want to know. And it tells us the angle of depression. So when John looks down from his eyes, so he's going to have 40 degrees here. So this is John looking down at his friend. And so we have enough information to find out how far John's friend is from the building. So we can look at this, and the 40 degrees, again, we don't know the hypotenuse, and we don't need to know it. So we're going to use tangent. So we're going to say, okay, we have the tangent of 40 degrees equals the opposite over adjacent. So opposite over adjacent is x over 17.8. So we're going to put x over 17.8. I'm going to multiply both sides by 17.8, and I can see that my answer is going to be x equals 17.8 times the tangent of 40 degrees. And that works out to be 14.9. So it rounded to the nearest tenth. So this would be 14.9, and our units are meters. So that means his friend is 14.9 meters from the building. Right, so here's one I would like you to try. I'm going to kind of walk through the problem description, and we'll set up a picture, and then we'll see if you can solve it. So it says standing in the gallery of a lighthouse. So the gallery is going to be up at the top. A person spots a ship at an angle of depression. So this person standing at the top of this lighthouse, and they're looking, if they were looking straight ahead, it would go this way, but they're looking down at this ship that they see. So you can see right here is the triangle we're going to be looking at. Here would be the right angle. And it says the angle of depression is 20 degrees. So the angle that they're looking down, this would be 20 degrees. And the lighthouse is 28 meters tall and sits atop a cliff that is 45 meters tall above the sea level. So the lighthouse, all right, so this is 28 meters. But again, it's on a cliff, and the cliff is 45 meters. So we got to take that into consideration, right? What is the horizontal distance between the lighthouse and the ship? So we want to know how far away this is, all right? And so we can see that this distance right here, this distance from, the lighthouse to the water, the top of the lighthouse where the guy's looking out to the water, is going to be the same as this distance right here. And so let's make our triangle. So we have our triangle. Actually, I want to use a pen, not that. All right, so here's our triangle. So we have an angle of 20 degrees here. This is our right angle. I want to know this distance right here, and I want to, I know that the height right here is 28 plus 45. So 28 is 13, and 4, 5, 6, 7. So this is 73 meters. Okay, so see if you can set up that problem and solve it. So pause the video and check your answer against mine. So this should have been set up in this manner so that you have tangent of 20 degrees is opposite over adjacent. So the opposite side over the adjacent side is x. So in this case, you have x in the denominator. So we're going to, when we solve a problem with a variable in the denominator, we're going to do two math moves. The first is we're going to move the x tangent, x times the tangent of 20 degrees is equal to 73. Then we're going to divide by the tangent of 20 degrees to move that to the other side. Remember, tangent of 20 degrees is just a number. We just haven't calculated out what it is yet. And so x is going to be 73 divided by the tangent of 20 degrees. And so, let's see if I can write that better. And so we'll do that on our calculator. Comes out to be 200.6. So we're going to say the ship is about 201 meters away from the cliff. So next we're gonna look at a cool problem that ties this trigonometry into algebra a little bit. So here we have an angle which is 36 degrees, and we have a right triangle because you can see that this this line right here, M, is a vertical line. This line N is a horizontal line. So we have our right triangle here. And we know the instructions tell you to find the slope of this line that's right here, this line that's going down. And how do we do that? Well, we know the slope of a line is the rise over run. And so you can see that from the horizontal that this particular line, it goes over N and down M. So the rise over run, this is the rise, is M. The run is N. And so rise over run in this case is just going to be the tangent. So the tangent of this is the opposite side over the adjacent side. And so we're going to say rise over run equals the tangent of 36 degrees. So what is rise over run? It's the slope. So that's what we need to find the slope. So we're going to take and we're going to calculate the tangent of 36 degrees on our calculator. Make sure it's in degree mode. And we're going to get the tangent of 36 degrees is 0.72654. It says to 4 decimal places, so our answer is 0.7265. Now we have to be careful here. This particular line, is it going up or down? It's clearly going down. And so in this case, it's going to be negative. And so this would be our answer here, would be negative 0.7265. So what does that number mean? Well, 0.75 would be 3/4. So we could think of this as just being a little less steep than negative 3/4, going down 3 units over 4. And those are your examples. So they should help you to look back at these when you do your problem set. Good luck.